Hello, my name is Caroline Donovan, and today I'm going to be talking to you about designing maps for scientific data for your data visualization course. Maps are powerful communication tools. The goal is to communicate information clearly and efficiently via a variety of maps. Effective mapping helps uncover trends, realize insights, explore sources, and especially tell stories. It makes complex data more accessible, understandable, and usable. Maps orient the audience to the geographic location of your study. Here on the right you see pictures of locator maps that are used as insets of bigger maps. Maps also provide spatial context and relationships between places. A lot of folks don't think about how they relate to different areas around the Chesapeake Bay or in their local stream, and putting it on a map can see, oh, I'm here, and all the sampling is being done right downstream from where I live. Maps can connect discrete sampling points to the larger picture. So yes, you might have one small study site, but how does that relate and connect to the areas around it and the other impacts that are happening around it? Maps are a visual tool for invisible science data. This is something that we struggle with a lot with the public, is trying to convey to them why things like water chemistry and microbes are important, and putting it on a map can help them actually visualize these, invisible science parameters. Okay, so reminder, these are things that you saw in your previous course lessons. Everything that you've already done in this course can be applied to maps. So for colors, making sure it's meaningful and visible, and you can test for perception for color blindness. There's parts in Adobe Illustrator that can do that, as well as you can go online. Size and legibility. You want to make sure on a map that your text is legible, and also that the sampling points or whatever you're using is big enough on the map for people to read. The fonts keep simple and readable. Informative labels and titles increase information density. This is especially important for legends on maps. Every map has to have a legend that also includes a scale bar, and that information increases the user's understanding. It does not confuse them. Be consistent with your formatting choices. And when you're making a map, make it with the same fonts and colors and everything that you're also using for the PowerPoint presentation that the map is going in, as an example. Or if you're making a poster, you want to be consistent with your formatting choices. The appropriate file type for your final product for this, depending on what software program you're using for mapping, you're going to export as a SVG, a .ai, or a .eps file. These are all vector-based images that can be edited in Illustrator. So choose the right fonts. You want them to be easy to read. I prefer sans serif fonts for maps. You're not reading text in a big long paragraph, so sans serif is better for short phrases and labels. Use color modes correctly. This is also useful. In Illustrator, you're going to set your mode to either be CMYK or RGB based on what your product is going to come out as. And remember, your map being projected on a screen can look very different from the map that's printed out of a color printer. And so you want to make sure you're checking both those things and using the appropriate color mode. So what not to do? Ask yourself first, is the map useful? On the right-hand side, you see here a map of South America, and each country has its flag as the country. But I have no idea what flag is for each country, so I still don't know which country is which on this map. Unless you labeled it with the name of the country so that the name of the country connects to the picture of the map, the flag, you're not going to be able to use this map. It's not useful to the reader. Always ask yourself, is the data saying something meaningful in map format? You don't need to use a map for everything. Perhaps a graph would work better, or some kind of figure. Always check the map for inaccurate data. Is the map actually showing you the right data? As an example, if you go into ArcGIS and you create a large map full of colored dots, you want to make sure that the colors correspond to the good or bad, I'm using quotes here, good or bad levels. So if you have a high nitrogen content and your colors are green, is that really conveying the right information? Also, you want to check for inaccurate legends. Is the legend using the right units? Is it telling you exactly what's on the map? And is the scale bar accurate? From design principles, you want to think about your fonts. Are they too small? If it's too messy or busy, that's not good either. And using color gradients is a useful tool, but don't overdo it with lots of fluorescent colors. So when you make a map, you want to ask yourself, what do you want to convey? What data is available to convey that message? And what kind of data is it? And when I say what kind of data, I mean, is it point data, where it's X, Y, and coordinates? Is it a line, or is it a polygon? These are different kinds of spatial information that you can put into maps. And so in more detail, this table provides the two different kinds of basic maps that we're going to use. Vector-based maps comprised of discrete coordinates that can be represented as points or connected to create lines or polygons. And these are all vector-based, so they're editable. And so you see here kind of the pros and cons of using different maps and what they convey. A raster-based map is very different. It's not editable. It is made to be a grid of cells in continuous space. And so a very common example of this is bathymetry maps. Almost all bathymetry maps come as raster-based images, and you can't edit them in GIS, but we will go over how you can kind of work around them in Illustrator. So first you want to draft your map. So use anything at hand, whether it's paper or whiteboard, get some colored pencils or markers out, and explore ideas or options for your maps. Maybe you end up drawing a map and you realize it's really long and narrow, like the Chesapeake Bay. How is that going to lay out on a slide easily? Should we turn it on its side? Should we cut it in half? These kinds of things. You always want to draft up a map while you're drawing. Then you're going to go to your GIS software, whether it's QGIS or whatever, and you're going to put in all your layers. You're going to add your base layer, maybe it's the Chesapeake Bay outline, the rivers, and you're going to add your data. And this is really useful for looking at your data, finally seeing what it's saying, using the symbology and the attributes table to take a look at what your data is really saying. And it's preparation for the final product. So you're going to export your map from GIS software, making sure that you have all the layers you possibly need, and maybe some layers you may not need in the end, but you can always hide. And you also always want to export with a scale bar and a legend. So the scale bar especially, it needs to move with the map, and when you take the map and put it into Illustrator, these two components become completely separate. And so as you're rescaling in Illustrator, you need to make sure you're scaling your scale bar appropriately so that that information is, again, still accurate. You always want your maps to be as accurate as possible. I'm only going to touch on spatial analysis very briefly. We're not going to go into it that much in this course, but the idea is that spatial analysis, it helps to analyze data in a spatial scale using algorithms and modeling. And so as a definition, what we have from Wikipedia, it's very confusing, I think. Spatial analysis or spatial statistics includes any of the formal techniques which study entities using their topological, geometric, or geographic properties. It includes a variety of techniques using different analytical approaches. And for us, this is really about looking at geographic data and applying human scale processes on a spatial layer. And so how does spatial analysis really happen? Well, first you have your maps with your single data sources. You might integrate different types of data sources, and you can actually create algorithms and models that say something about the spaces in between your data and what that's really showing. And so that's kind of the basic of it. Interpolated maps are just one type of spatial analysis that I'm going to go over. So interpolation means estimating new data between known values. So what you see here on the left is a map of discrete sampling points, and you can see based on the colors of those sampling points what is happening at that sampling location. However, what interpolation does is create algorithms that come up with values between the other discrete sampling points, so that you get to see these kind of patterns that develop from the interpolation process. So that's just one example, and it's very common, and there are interpolated maps available online. So for this class, we're going to do a base map production and layering exercise in the class. So in your mapping software, you're going to add all the layers you need, including those that you may not need. And don't worry, we can always hide these layers later on. In the mapping software, you're going to export your map as .svg, .eps, or as .ai. Then you're going to open that file in Illustrator. You don't need to copy and paste into a new artboard. Just go to the file in your folder and click on it, and it will open in Illustrator. It'll ask you what software to use. So examples of good maps. This is sometimes called the ghost map, but it is a great use of a hand-drawn map that was done by Dr. John Snow in 1854 during a cholera outbreak. And what he did is he mapped on the streets of London where the deaths from cholera were and where the water pumps, because back then people had to walk to get buckets of water from pumps. And so you can see how they cluster around the one water pump on Broad Street, and that is right here. And they took the pump out and the cholera subsided. On the right-hand side, you can see actually the same map reimagined in today's world, and so it's a heat map where they used bigger dots to indicate more deaths, and you can still see again that this cluster of deaths right around this same pump. On the left is an example of something that we did for the Coastal Georgia report card, and it was a large area, but they really wanted to show the different habitat types that were along the coast. And so what we ended up doing was this kind of blowout of the coast and used different colors for different habitats, but then as habitats overlapped, we ended up putting these kind of open squares on top of the other habitat to try to indicate, this overlapping habitat use. On the right-hand side is an example that's online at harboralert.org, and what you see is a satellite map showing the urbanization or impervious surface around Baltimore, and then this is overlaid with fecal coliform data that's been scored on basically a high, medium, or low risk of contact with the bacteria. And they actually have a lot of different indicators that they've put on this map, but I think the important part is to share this data online, but also having that overlay of impervious surface and showing how impervious surface also affects the water quality. Another example from Baltimore is this report card map that they made of the watershed, and so I like that it's kind of providing this really unique look with the north arrow being different and the edging being different. The roads are really nice. I think that it's a little busy with all the grades for each individual sampling point. I think if they had just highlighted the colors of the watersheds, that would be good. They do have a legend and some more information in the top right, and then an inset map of the fecal bacteria, because the main map is not fecal bacteria, it's water quality. And so this provides a lot of information in a small amount of space. On the right-hand side is an example of an interpolated precipitation map, and this data is available. These data are available to anyone that wants to use them throughout the United States, and you take specific precipitation measurements and you can make these interpolated maps to see what the patterns of rainfall might have been over the past year. Here's an example of using a base map and then creating almost like a conceptual diagram. So the South Atlantic Landscape Conservation Cooperative, you can see the little inset map here, wanted to orient their readers to the area. So what area is covered by the South Atlantic LCC? We used state lines to put this on a map. We used the fall line to orient people, and then we added cities, major cities of each state, and then populated this map on top of that with things like where military bases were, where a historic site is, energy and industry. They had certain topics they were covering in their product. So examples of bad maps, hopefully this map is an example, especially considering the ones we just looked at. This one is too messy, too many colors, the font sizes are tiny. How can you really get anything out of this? It's just cramming too much information. Now, CatastropheWordPress.com is a really good blog about different maps and why they're bad, and I think going through that process and that exercise is really important for all maps. Here's an example of a map that's it's very confusing. It's too basic in some ways. You have a lot of little cities, and then the weird part about this is that there's a legend, and it just says Karan or Karan, and yet everything else is labeled on the map. So you could have just labeled this city on the map directly. Besides which, they don't indicate where there's water or where there's land. You see the Italy, Belgium, and Spain kind of floating in mid-space. And then this is just an example, obviously, again, of one that's too busy. Someone must have searched for something and tried to overlay it with other things, and it just became way too much, and it's not really useful information. So as your resources, you can always email us. My name's Caroline Donovan. It's cdonovan@umcs.edu. Heath Kelsey is also going to be co-teaching this part of the class with me, and his email is listed. We also have a blog called 10 Classic Scientific Maps that would be useful. And then if you go through some of these online resources, they're really just to provide information about what maps look like, what they're good for, what they're not good for, just more details about maps. One of the things to look for in the future is that Esri has connected with Adobe, and they will be providing maps for Adobe products in the future. And so that should come out later in 2016, and it's something to keep a heads up on. So thanks, and see you on Thursday. Please bring a vector or editable map of your own to show the class on Thursday. This will be the map that we're going to edit in Illustrator and that you're going to show on the second week of the mapping part of the course.